is he getting stiffer?
A devil has possessed his limbs, and exorcism should do the trick.
That's not it. The reason for the stiffness, or rigor mortis, is muscle contraction. This model represents one sarcomere in a muscle cell. The actin, the thin filament, is the moving part, while the myosin, the thick filament, does the moving. The Z-line represents the border of such a sarcomere.
Contractions begin when the motor neuron sends an action potential down its axon to the muscle cell. Neurotransmitters are released from the end of the motor neuron, which triggers an action potential originating in the sarcolemma, or the muscle cell membrane, which travels down the T-tubule. As you can see, this is the sarcolemma. The action potential travels across the sarcolemma and down into the T-tubule.
This action potential sends a message to the sarcoplasmic reticulum to release calcium ions, which bind to the troponin of the actin. This causes a reconfiguration of the tropomyosin, which reveals the sites on the actin where myosin heads can bind. Myosin heads are part of the myosin, which pulls actin to contract the muscle. Myosin heads bind to myosin binding sites. When myosin heads bind to the actin, they are ready to cause the actual movement of the actin.
However, there's a few things that need to happen before we can get to contraction. First, ATP must be present for the myosin head to move from a low energy configuration to a high energy configuration. Ready for action by hydrolysis of the ATP into ADP and a phosphate group. Only can the high energy configuration bind with the actin. The heads bind tightly with the actin, forming a cross bridge. As the myosin performs the power stroke, which more greatly overlaps the actin and myosin, causing contraction, ATP and the phosphate group are displaced. More ATP is used to remove the myosin heads from the binding sites. Returning to its initial low energy configuration, this ATP will be used to repeat the process.
If there are more calcium ions present binding to the troponin, the contractions will continue to occur until the motor neuron stops sending signals via the action potential for the release of calcium. Now, how exactly does this connect to rigor mortis? After the body dies, it no longer produces ATP, or rather a significant amount of ATP. As you may remember, ATP is required for myosin heads to release the cross-bridge and prepare for another cycle. However, membranes in the muscle cell dissolve, which releases an inordinate amount of calcium into the sarcomere, leaving all the binding sites available. As time passes, more and more myosin heads bind to actin and perform the power stroke without being able to dissolve the cross-bridge. This leaves the actin and myosin in a very rigid position, causing the phenomenon rigor mortis. So it's not the devil?
As I tell you, it is.
It's just muscles.